Welcome to G Fun Facts Online. An invisible current is reshaping our world. It's not a physical force, but one born from data and algorithms, a kind of synthetic imagination we call generative artificial intelligence. This technology, which learns from vast amounts of information to create entirely new things, has leaped from science fiction into our daily reality. It's a powerful collaborator in both scientific labs and art studios, sparking a modern renaissance that challenges our very understanding of what it means to create and to discover. Today, we're exploring how this synthetic imagination is fueling breakthroughs in both science and art. For centuries, the scientific method has been a purely human endeavor, a slow, painstaking process of observation, hypothesis, and experimentation. Now, that entire process is being supercharged by AI. Scientists are partnering with generative models to tackle some of our most complex challenges in medicine and materials science, achieving breakthroughs at a speed that was once unimaginable. Let's start with medicine. The journey of a new drug, from an idea in a lab to a pill in a pharmacy, is notoriously long and expensive. It can take over a decade and cost billions of dollars. At its core, drug discovery is like searching for a needle in an astronomical haystack. You're looking for one specific molecule that can bind to a biological target, like a protein, to fight a disease without causing harmful side effects. Traditionally, this meant manually sifting through millions of known chemical compounds. Generative AI is changing the game. Trained on the very language of chemistry and biology, these AI models can dream up and design entirely new molecules with specific, desirable properties. Instead of just searching the existing haystack, we can now ask the AI to generate brand new needles that are much more likely to work. A landmark achievement in this area came in 2020 with the discovery of halicin. An AI model at MIT identified this molecule as a powerful new antibiotic. What's incredible is that the AI found its potent capabilities against drug-resistant bacteria with remarkable speed and efficiency. It was a game changer. Following that, companies like In Silico Medicine have used generative AI to take a new drug for a lung disease called idiopathic pulmonary fibrosis, from the initial idea all the way to preclinical trials in just 2.5 years. The traditional timeline for this is about 6 years, and the AI did it at 1/10 of the cost. So how is this incredible acceleration possible? It comes down to a few key applications. First is protein structure prediction. Proteins are the microscopic machines of life, and their function is determined by their complex three-dimensional shape. For decades, predicting how a protein would fold into its final shape was a monumental challenge in biology. In 2020, DeepMind's AlphaFold revolutionized the field. It could predict these structures with almost the same accuracy as a real-world experiment. By 2022, AlphaFold had mapped over 200 million proteins. This provided an unprecedented atlas for understanding diseases like Alzheimer's and for designing new drugs to target them with precision. Second, there's something called ADMET prediction. ADMET stands for absorption, distribution, metabolism, excretion, and toxicity. These properties determine how a drug will behave inside the human body. A drug might be great at fighting a disease in a petri dish, but if it's too toxic or the body gets rid of it too quickly, it's useless. Generative AI models can estimate these ADMET properties very early in the process, flagging potentially toxic or ineffective candidates long before they reach expensive clinical trials. This dramatically reduces the risk of costly failures down the line, but perhaps the most futuristic application is hypothesis generation. AI isn't just analyzing data anymore, it's starting to ask new questions. Systems like Hyper and MIT's SciAgents are being developed to autonomously generate and evaluate promising research hypotheses. They do this by mining vast libraries of scientific literature, looking for patterns and connections that a human researcher might miss. This shifts AI from being a mere tool for analysis to an active partner in the creative, ideation phase of scientific discovery. The same principles that allow AI to design new drugs are also being used to design the materials of tomorrow. This has led to a new era of what's called inverse design. Traditionally, discovering new materials was a slow process of trial and error. You would mix different elements and see what you got. Now, with inverse design, scientists can specify the properties they want, like extreme strength, high conductivity, or sustainability, and then task a generative AI to design a material that meets those criteria. In 2023, Google DeepMind's GNOME tool made headlines when it predicted the existence of 380,000 new, stable crystal structures. To put that in perspective, this achievement is estimated to be equivalent to nearly 800 years of traditional laboratory work. These AI-generated materials hold the promise for developing next-generation technologies, like much more efficient batteries, better solar panels, and even superconductors. Microsoft's MatterGen is another powerful tool that can generate novel materials directly from text prompts, allowing researchers to explore a vastly larger space of possibilities. By embedding the fundamental laws of physics and chemistry directly into the AI's learning process, scientists are ensuring that the generated materials aren't just mathematical curiosities, but are chemically realistic and could actually be created. Now, let's shift from the laboratory to the studio. While science harnesses generative AI for discovery, the art world is embracing it as a powerful new medium for expression. AI art generators like Midjourney, DALL-E, and Stable Diffusion have captured the public's imagination, allowing anyone to create stunningly complex images from simple text prompts. But the impact of AI on art goes far beyond just generating pretty pictures. It's fostering a new kind of collaborative creativity, blurring the lines between the artist and the tool. Artists have actually been experimenting with AI since the 1960s. A pioneer named Harold Cohen created a program called Aaron, which could generate its own unique drawings and paintings. But today's tools are a quantum leap forward. And importantly, they're not being used to replace human artists, but to augment their creativity, acting as a tireless collaborator and a source of unexpected inspiration. For example, the Turkish-American artist Refik Anadol uses vast data sets and AI algorithms to create mesmerizing, large-scale data sculptures. His work transforms abstract streams of data, from ocean currents to human brainwaves, into fluid, dynamic visual experiences that turn the invisible world of data into breathtaking public art. Another artist, Linda Dunya from Senegal, trains AI models on her own abstract paintings. She uses a type of AI called a Generative Adversarial Network, or GAN, to explore how AI art can feel as spontaneous and meaningful as traditional art. She creates thousands of unique images inspired by her own style and cultural touchstones. Perhaps one of the most famous examples was the Next Rembrandt project in 2016. A team of scientists and art historians used AI to analyze Rembrandt's entire body of work. The AI learned his signature lighting, his brushstrokes, and his compositional style. It then generated a completely new portrait that was uncannily similar to the style of the old master. These examples show a fundamental shift in the creative process. The artist's role is evolving. They are becoming curators, prompters, and collaborators with the machine. The AI can generate countless ideas and drafts in seconds, freeing the human artist to focus on the bigger picture, the concept, the refinement, and infusing the work with a personal vision and emotion. The world of music is experiencing a similar transformation. AI music composition tools, from sophisticated platforms like AIVA to user-friendly apps like Suno, can generate original melodies, harmonies, and even fully orchestrated pieces in almost any style you can imagine. The process starts by training a neural network on a massive data set of existing music. The AI learns the patterns, structures, and relationships between musical elements, from the chord progressions of Bach to the rhythms of modern electronic dance music. It can then generate new compositions that either stick to those styles or blend them in entirely new ways. This technology is being used in a few different ways. For composers, it can be a creative spark to overcome writer's block, generating new melodic ideas or backing tracks. It's also incredibly efficient at creating high-quality, royalty-free background music for films, video games, and commercials. And just like with visual art, it's democratizing creation, allowing people without formal music training to create original pieces just by specifying a mood or genre. But the rise of AI-generated music has sparked a fascinating debate about its emotional resonance. Can an algorithm really create music that has soul? Some argue that it lacks the emotional depth that comes from human experience and suffering. Some studies have shown that when listeners know a machine composed a piece of music, they often perceive it as more emotionally flat. And yet, other research using biometric measurements like pupil dilation has shown that AI music can trigger strong physiological responses in our brains, suggesting our minds are working hard to process and find meaning in these new, artificial compositions. Of course, this incredible new power in both science and art comes with some incredibly complex challenges and philosophical questions. As we delegate more creative and cognitive tasks to machines, we're forced to confront fundamental issues of authorship, ethics, and the very nature of human intelligence. One of the most immediate and fiery debates is about copyright. Generative AI models are trained on enormous datasets of text, images, and music, much of which has been scraped from the internet and is protected by copyright. This has led to a legal and ethical crisis. Artists and creators argue that their work is being used without their consent or compensation to train systems that may one day compete with them directly. The legal doctrine of fair use is being tested like never before, as courts grapple with whether training an AI is a transformative new use of data or simply large-scale infringement. In response, some companies like Adobe are trying to develop ethical AI models that are trained exclusively on licensed data. This debate strikes at the very heart of intellectual property rights and the future economic landscape for all creative professionals. Another major issue is bias and the black box problem. AI models are only as good as the data they are trained on. If that data contains historical biases, and most of it does, the AI will learn and amplify those biases. This can lead to skewed results in scientific research or the generation of art that is stereotypical and non-representative. Furthermore, many advanced AI models operate as black boxes. This means their internal decision-making processes are opaque, even to the people who created them. In science, this is a huge problem. The principles of verification and reproducibility are central to the scientific method. If scientists can't understand how an AI arrived at a hypothesis or a result, it becomes incredibly difficult to trust that finding and build upon it. This raises serious concerns about a potential flood of junk science that can't be properly vetted. So where does all of this leave us? If a machine can create art, compose music, and generate scientific hypotheses, what is the role of the human artist or scientist? The emerging consensus is that AI is not a replacement for human intellect, but a powerful partner that augments it. In science, human judgment, intuition, and critical thinking remain essential for defining meaningful research questions and interpreting the results that an AI generates. The AI can handle the massive computational grunt work, freeing up researchers to focus on higher-level, conceptual thinking. In the arts, a model of human-AI collaboration is emerging, sometimes called the centaur model, referencing the mythological creature that was half human, half horse. This model suggests a future where creativity is a fusion of human vision and machine intelligence. The human artist brings intention, emotion, and cultural context, while the AI provides new possibilities and technical capabilities. This partnership doesn't diminish human creativity. It could even lead to a renaissance, pushing artists to explore entirely new forms of expression. The synthetic imagination of generative AI is already here, and its influence will only continue to grow. We are at the dawn of an era where the partnership between human and machine intelligence will unlock unprecedented breakthroughs. In the lab, it will help us solve some of humanity's most pressing challenges. In the studio, it will give rise to new artistic mediums we can't even imagine yet. Navigating this future will require a balanced approach. We must harness the immense potential of this technology while developing strong ethical frameworks to address issues of bias, copyright, and transparency. The future is not one of humans versus machines, but of humans and machines creating and discovering together. Thanks for tuning in to G Fun Facts Online.